Oh shit. I've been talking this entire time with my microphone off. Gotta be kidding me. I just wasted my breath for. Actually, it was for not. It was not for nothing because I'm doing this for my for improving my explanation. It doesn't matter if anyone sees this or not. So it was actually not for nothing, but I wish my microphone was on. Anyway, we cannot change that now, can we? Whatever happened, happened. Have to watch out for this next time. Mm, okay. I hope my microphone is working now. But yeah, so it is working now at least. Let's get back to solving problems, shall we? For a pair xy, that its difference is defined as absolute x minus y. I've already read these parts. Determine the minimum possible value of the maximum difference, of course. Let's see the constraints, and depending on the constraints, we have to come up with the perfect um, solution. I mean, perfect time complexity solutions. Whether it's n square, n log n, and log n, whatever that is. Let's see. Test case, got it. The first line of each test case contains one even number n, and it's between 2 and 2 times 10 to the power of 5. That means we already know that we cannot use n square solution. We have to use n log n or n out of 1 if that's possible. I think not. I think we have to go for at least n log n. The second line, an integer, negative 10 to the power 9 to positive 10 to the power 9. The element, they're huge. It is guaranteed the sum of values. Okay. For each test case, output a single number, the minimum possible maximum difference between the elements in pairs. I mean, we have to organize the pair and we have to make sure that the difference is less. How can we do that? In the first test case, 1 2, the only possible optimal pair is 1 2, and the difference is 1. The answer is 1. I mean, it seems like we have to make the pair such a way that the values are close enough. I think we have to sort the array, and that way the values are close enough. Each pair is close enough, right? Second test case, 10 1 2 9. I mean, if we sort it, we get 1 2 9 10, 1 2 9 10, and that's how you do it. And for this one, 3 8 9 3 3 2, so 2 3 3 3 8 9, so 2 3 3 3 and 8 9. Got it. Is there any catch other than that? I mean, seems like to me the solution is just sort it and make them a pair, and then just count the difference. There might be a catch, but we shall find out once we do it. Let's make a manual test case to check if there is any corner case. That obviously they won't provide corner cases here, right? So we have to figure out the corner case. Let's put the problem here on the right side and then my whiteboard on the left side. So let's make a corner case. 2. Let's take random values for now, hoping to get the corner case. Oh, -1. I think -1 here, I mean the negative values can be a corner case here. Like, what if we have one -20, then 0, and then 5, 8, 12, 21. If we sort this, we already talked about sorting it, didn't we? Oh, I wrote the value already sorted. Then suppose they're scrambled, okay? Then we sorted it, and now we're gonna make them pair. Like, we're gonna pair these two because we said that they're close enough. Then we pair this, but I think there is one more way that we can pair it, and then the absolute difference can be minimized. First, let's see what the difference is. 20 minus 0, or -20, minus 0, which is -20, but the absolute value is 20. And then 5 minus 8, absolute value is 3. 12 minus 21, absolute value is 9. So the sum is 32. Okay, but you know, how can we change it? I guess you already guessed that how am I gonna change it. I'm gonna put 0, 5 together, 8 and 12 together, and then -20 and 21 together. Let's see how that changes our absolute value to 0 minus 5, 5, 8 minus 12, 4, -20 minus 21. Wait. Uh, for pair, its difference is defined as x minus y. So x is -20 and y is 21, and -20 to -21 is 41. I thought I mean, honestly, I thought there was gonna be 1 just, but I think I misunderstood something. I'm not good at math, that's why, I guess. Okay. It's because they didn't say that it's like this, like absolute x minus absolute y. It's just absolute x minus y, so that's why that is. And it's not 1, it's -41. That means it's actually 41, which makes the whole thing a lot larger. Then I guess that is the optimal way. We should not change it. I guess I'm gonna make the solution just like I thought before, organizing them in a sorted way, and then make them a pair and be done with. And if that doesn't work, then we're gonna change something. So we have test cases and we have our n. Why it's not fully shown? To make it smaller. Okay. I mean, I can read everything, so it's fine. And I hope you guys also can read because the stream quality is high and you should be seeing this. Okay, let's take the values. Take a vector. I always name this store, that's how I like it. Take all the values and then store them inside the store vector. And now we talked about sorting the array, didn't we? So let's do that. Now we have our array sorted in just one line thanks to the built-in function. And now just see the result. So for diff, okay. Okay. We only need to iterate n divided by 2 times, right? Like half of n, because we're making them pair. N by 2 and equal 1. Okay. We have to iterate only half of the number of elements, and then we also need another variable for accessing the indexes. So it's gonna start at 0, but we are not gonna increment that here. We're gonna increment it in this place. Or we can increment that here. That's gonna make it easier, I think. Increment it by 2 because we're taking 2 values each time, right? That's why. Okay, so diff plus equal absolute value, okay. Store j minus store j plus 1. Got it. And that's gonna give us the difference. Let's print that and let's see. For this test case, we counted that um, 32, right? Okay, so the difference is 1 plus 1, 2. So for the third test case, we have a difference of 2. Let's see if we got that correct or not. That should give us 2. Okay, so we got that correct, but that's not the answer they're looking for. They're looking for the largest is 1. So difference, so the maximum difference among all pair is minimized. Okay, so maximum here is 1. So yeah, that's what we need to find. So we don't need to make the summation of the differences. Okay, we have to check where's the minimum maximum difference. So let's take min equal L long. Okay, so if difference actually we are storing the maximum, not the minimum, are we? So it's supposed to be along mean. So if difference greater than max equal diff cout max. And for the third test case we should get the result 1 because that is the maximum difference we got. Let's check for the entire thing. We shall find any corner case. If that looks like it's working for the test cases here, but I'm pretty certain that there is a corner case that we missed. Should I submit this? uh, yeah, let's see if we got this correct. Let's check a corner case before I do that. I mean, what is the trick that I might have missed? Because it's not supposed to be this easy. Or is it? I'm so confused. Tell me. Oh well, would you look at that? It's accepted. I guess because it's a div 3, so the first 2 or 3 problems are easy. So I should not think way too much than I should. Max rows. You are given an array A of length n and a number k where k is between 0 and n. So k is not greater than the length of the array. So can the length be 0? I guess not. In one operation you can choose any index. Got it. Can choose any index and set ai to the to any integer value x from the range 0 to 1. So I can simply choose any index and make the value anything I want, but the value has to be between 0 and n. Find the minimum number of such operations required to satisfy the condition mix actually not max mix a times equal k. Max a times equal k. What is that? Oh, a times equal k means a a equal a times a, oh, a times k actually, not a. What is mix? The minimum excluded of a set of numbers a1, a2, and is the smallest non-negative integer. The minimum excluded, the smallest non-negative integer x that does not appear among the AI. Oh, this star doesn't mean that AI a times k. It's not. That star is just for this one. That was really confusing. It's just that max a equal k. That's it. So the minimum set of numbers AI is the smallest non-negative integer. So it's small and non-negative. That means not negative but 0, 1, 2, whatever, positive integer x that does not appear among the AI. So okay. So basically in this array there has to be every value before k, simply from 0 to k minus 1. Every value from 0 to k minus 1 has to be inside this array. Let's take the problem name. So let's take a comment. Let's write a comment like every value from 0 to k minus 1 has to be in present. What? Present inside the array. And it doesn't matter after k minus 1 has to be inside this array, and then it doesn't matter if k or k plus 1, k plus 2 values are inside the array or not. It doesn't really matter. Okay, what matters is 0 from k minus 1 has to be present, simply. That's all we have to do. So let's see, for this test case we have 1 and 0 and k is 0. First one is the test case and then nk. Oh, I see. This is n and this is k, not this. I thought this one is k because there is. Okay, let's see for this big constraint or test case, whatever you call it. It's n and this is k. So n is organized this way. Let's take it over here in our whiteboard. Let's make it slightly bigger. and what was our k? It was 2. So our k is equal to, and what I said that every value from 0 to k minus 1 has to be present inside this array. So is every value? Let's organize this. Okay, sort this in ascending order. There is extra 2 here. 3 4 6 1 2 3 4 5 6 1 2 3 4 5 6. Okay, got it. So every value from 0 to k minus 1 has to be present. So 0 1. So 0 is present but 1 is not present, so we have to make a value equal to 1. And how we do that? We can choose any index and set ai to any integer. Okay, we can choose any index. Why not choose this one, or whatever you want to choose? It doesn't really matter. Make it 1. Okay, now we have 0 and 1, but not not just that. There's one more thing. I mean, they said that the minimum excluded is that the smallest non-negative integer that does not appear in the array, and that value has to be equal k. So obviously k cannot appear in the array. You see, we cannot have k inside the array. So we changed 1k when we changed this to 1, and there is still one more k left, so we have to eliminate that. Doesn't matter what you change this to. Okay, doesn't really matter as long as it's not present. Okay, so one more rule, which is k cannot be present in the array. That is the only two rules we need to watch out for. Okay, and how are we gonna do that? How are we gonna solve that? Obviously we need to sort it first. Yep, let's do that. They have test cases, take it. They have n and they have k. Take those and then take n values, store them inside our good old store vector. Okay, I should also make a shortcut for this one too, because it's the same always, right? But let's do this manually because it's not always the same. And if I always do shortcuts, I might forget some stuff. Okay, because the shortcut only works for this laptop I have, because I set those, and if I move on to a new computer I have to again set those, which is gonna take a lot of time. You see? So what next? Yeah, sort it. Sort the array. Now what I said, that every value from 0 to k minus 1 has to be present. So let's say we are iterating each of the indexes, and if we see an empty index, suppose k is 5, we see we have 0, good, we have 1, good, we don't have 2. what are we gonna do? We have to change. Wait, someone's calling me. Alright, I'm back. I had to take a call. So, where were we? Uh, yeah, I guess we were doing something like. Yeah, so because k is 5, and now here we also need to fill up everything, like every element from 0, 1, 2, 3 to n k minus 1. So we have found 0, 1, and there is no 2. So what we have to do is that we have to change 4 into 2. Then 3 doesn't need to change, and then this doesn't need to change as well. And also, lucky for us that there is no 5 inside that array, otherwise we would have to remove that as well. So now that we get every element from 0 to 4 and there is no 5, this is the perfect array. But what is the actual output they want? The minimum number of operations required. Okay, what is the operation actually? The operation that you can choose an index and then change. So yeah, changing. How many times did we change? How many times did we change an element? Only once for this um, manual test case. Yep, and that's all we have to do. So let's iterate the array with a traditional for loop. Okay, so we need to first we need to check out only only till n minus only till k minus 1, only till k minus 1. Okay, so from 0 to k minus 1. Okay, got it. And because the array is sorted, if the first element is not equal to I, in this case 0, then we have to change that element to 0. But there is an issue, a big issue, which is let me show you what if the array is like this. Let's not put any 5 here. Okay, okay, after sorting this, it's gonna become 6, 7. Alright, let's say k is equal 5, n is equal 0, 1, 2, 3, 4, 5, 6, 7. Now we said that we have to have every element from 0 to k minus 1, and then we sorted the array and we checked that the first element is not equal 0, and we were about to change this to 0, and then we were about to put 1 operations here, and then again, because this one is not equal to 1, we were about to change this to 1, and then you know, again add 1 operations and then so on. But that is a mistake. We have to change, if we do that, we have to change every element from here, but we already have 1 to 4 element. We just need 1 operation, we just need 1 0, which we can get from either of these other values. Let's take this value, change to 0, put it here, and we only have 1 operations, not for each of these like 4 or 5 operations in total. So we cannot change items from here. We have to check from first index. I mean, we have to check if, I mean, how many of the values from 0 to k minus 1 is present inside this array. Okay, that's what we need to check out for. So let's check. So if I is not equal 0, so how do we check that? The values are, the n is 10 to the power 5. Okay, we can use hash map, right? Let's use hash map. Okay, simply to check if the elements are present or not. We can use unordered map, but that's gonna take that's gonna make the solution n log n. Let's try to it's actually already n log n because we used sorting, but still I'm not gonna use unordered map because each operations take log n time. I'm gonna use this hash map using vector, which is gonna do the job at order of n, or if we are looking for any element, it's just order of 1 operation. Okay, so hash map n plus 1 0, because if the element is present it's 1, otherwise it's 0. So this element is present, that means hash map value equal 1. Now I'm able to do that because they told us that the value is not greater than n. That means we don't need indexes greater than n, do we? We only need indexes from 0 to n, and this is how we get all the index from 0 to n. Okay, I'm not gonna explain every details like why it's n plus 1. You can figure that out. So from 0 to k minus 1, if hash map I is equal to 0, that means it's not present in the array. That means we can count like not present. We can increase not present by 1. And if then later if 1 is not present in the array, then again not present plus plus till k minus 1. So suppose here, let's remove these two. That means 1 is present, 2 is present, 4 is not present. That means 2 is not present. We should get 2 output. Let's debug it. Okay, let's see if we are getting the correct answer. come on. Okay, so we should get 2 for this thing. It's actually 7, so let me just add a few more elements. 1 2 3 4 5 6 7. Test case n equals 7, k equal 5, 1 2 4 6 6 8. What just happened? Did I miss something? Oh, because, yep, why did I put 8? I know that n is 7 and they said that the value cannot be greater than, and that was my fault. Let's try that again, okay? This time with the correct way and eliminate the wrong value. Why don't just put another 6, okay? What happened? 1 7, k is equal 5, and then the values 1 2 4 6 6 6 7. Got it. The result is 2, meaning 2 of them are not present in the array, and that means we have to do 2 operations, right? Because to make a 0 here, we have to take an element from anywhere of the array. Suppose imagine that we took any of the element and make it 0 and then just remove it. I mean, we don't have to actually perform that in here, like we removed that, perform that in code here. We don't need to do that. Okay, and for putting 3 here, we also have to move another variable, like suppose we move this one, but we don't actually have to move this one with code. Just imagine we moved it. Okay, so it's 2 operations. So this is actually the result. We don't have to do anything else. We can just print this. We don't have to actually move the array, do we? We don't have to actually move the array element. Let's see if it's working for these test cases. 0. Wait. It's not same. I think we missed something. It's okay. Let's see what we missed. Oh wait, I said that another thing, I mean the second rule, k cannot be present in the array. We didn't watch out for that, did we? What if there is a k here? We also have to change that, but we didn't do anything for this. So how do we do that? So we have to count how many number of k in the array. I mean, k can be multiple times present in this array, like every element could be k also. I mean, who knows? Let's check how many k there is. So let's check how many k there is, right? Simple. For I, actually, let's take a range based for loop and be done with. If point equal k, that means let's name it k present, okay? K present plus plus. Is my microphone on or did I turn it off again? I hope not. I mean, it's on, so no problem. So now we have the number of k present in this array. Let's change this because not every element is k. Suppose we have 2 k's, okay? 1 2 3 4 5 6 7 6. So there are 2k and two of them are missing. So two of our element is missing and we have 2k inside. So why don't we, instead of changing other values to 0 3, why don't we change our to 5 we have here. I mean, we are killing two birds at one strike, right? We are adding unnecessary element as well as deleting the unnecessary. Right? So yeah, so there's a calculation here, right? So we have two necessary element and two unnecessary. That means instead of 4 it's just 2. 4 is how, if we change this to 0 and this to 3 and remove these two, total 4, but actually taking 2. So the calculation here is I guess minimum of unnecessary element, I mean necessary and unnecessary element, necessary unnecessary element. Here necessary is 2 and unnecessary is also 2, so the result is 2. What if we need necessary element 3 and unnecessary like 5 is 1? The minimum operation then is gonna give us 1, but we actually need 2, right? Actually we need 2 because we need 3 element and we have one unnecessary element. We can get one element and remove one element at the same time. Get one value and remove one, that is one operations, and then two other operations, so 3 operations total. It's actually max simply not min. Yep, obviously it's max unnecessary and necessary, because what if we have something like this time we only need 2 element and there are unnecessary 5 elements, so we need necessary unnecessary, we need 2 elements and there are 5 elements that we have to remove. So let's see the operations. In one operation we can take one necessary element by removing one element, that's one operations, and then again 2 operations, and then here we also have to remove these 3 unnecessary, that means these are 3, so total of 3 for 5 operations, which is max to 5, which is 5. Yep, simple. Just print out max not present, k present, that should do it. 1 0 0 2 2, got it. Let's submit it. Okay, with the comments. I mean, why bother deleting it? It can stay there, it's not harming anyone, is it? It also can be a note for others if anyone ever sees my code, so is it accepted? Thank God. Moving on to the next one. I mean, these were easy problems. If I mean, honestly, these were easy problems. And what is the standing? quite far behind. Any friends with me? Yoga. Shahjalah University. That guy is quite good. He solved G first. Hmm. 176 penalty. Okay, let's solve this. Given a string S of length n consisting only of the characters A and B. Okay. Given a string S of length n, we have a string S of length n consisting only characters A and B, which only has characters A and B, nothing else, just plain A and B. Okay. Alright, that's enough. Okay. Plain A and B. Got it. That part. In one operation, you can choose a position I. Okay. In one operation, you can choose a position I n minus 1. I mean, you can choose positions till n minus 1. You can choose the last one, I think, and swap the neighboring characters si and si plus 1. Yeah, because of this, because you are swapping. Suppose if you choose this character, you are swapping the next one, the right next one. So if you choose this one, there is nothing in the right. It's gonna show a runtime error if I do that. So here, then you can choose the right one. So you can swap the neighboring characters. Swapping, we are. Okay. You need to perform the minimum number of operations to, again, minimum number of operations. What's up with them with the operations? You need to perform the minimum number of operations to ensure that all characters of one type, either A or B, are located strictly together. Are we doing this? This thing? I think. You need to perform the minimum number of operations to ensure that all characters of one type, either A or B, are located strictly together. What is strictly together? Is there a catch? Forming exactly one continuous block. Characters of the other type can be positioned either before or after this block. Of course, either after or before, however you like. That's what they said. Characters from forming two possibly empty blocks. Possibly empty blocks? What do you mean empty blocks? Can the string be 0? No. Yeah, what does it mean by empty blocks? Example of a valid final forms. Yeah, please give us an example. So I think by blocks they means 1, 2, 3. All B's are located together. One block. A's can be both before and after this block. I don't get it. Possibly empty blocks. I mean, there is at least something, even if it's all A or all B, still one block, right? I don't know how we're gonna get the empty block. Let's read the whole thing, then we'll understand. Example of valid final form. So this final form is valid, right? And this is also valid because B's are together here and A are together here. All A's together, B's are at the edge of the strings. Characters of the other type can be positioned either before or after this block, forming two possibly empty blocks. Strictly together. Oh, you need to perform the minimum number of operations to ensure that all characters of one type. Okay, we need to put at least one, like suppose this, okay? Here, either all B's are together or either all A's are together. Suppose you can, if we put all B together, then A can be here, other A's. But at least one element has to be all together. You cannot put even one B on the other side. Okay, that's what they said here and gave an example for. You need to find the minimum number of described operations. So what was the operation? Oh yeah, you can swap the neighboring elements. Swapping minimum. So suppose we have this, and if we swap, I guess we have to do I mean, do you have to bring smaller parts to the larger parts or bigger part to the smaller parts, or are they the same if we do that? I mean, either way we have to make them together, right? That's what we have to do. Let's see. If we move this B here, then A and A are together, just one. The constraints are big enough so that we cannot use n square solution. Let's see how many operations it needs to make all the B's together. So A, B, B, B. This B was not here before. There was an A here. And this B was here or somewhere here, I think. So swapping, right? So we're bringing this one here, so swap with this A. Okay, let's copy this. I mean, I don't want to write this again and again, really time consuming. Ah, why did I write A again? Oh, I can do that like this. Can you do that on notebook? Of course you can't. What just happened? Did I need to copy this one. This thing. What? Oh, I guess pressing Control C is not gonna work here, is it? But it did work now. What is happening? Control C, Control V. Got it? Come on, man. Copy this. I just copied this one. Why am I getting the previous stuff? This thing is so confusing. Oh, they're already here, so I don't need to do any other operations. 1, 2, 3, 4, 5 operations in total. So we moved all B together and it took us 5. Now we moved the smaller parts to the larger part. But what if we move the larger part to the smaller part? Are they gonna take the same amount of time? I guess not. I think it's gonna take much more time if we move the larger to the smaller. I mean, simply let me give you a visual. Like there is a large block of B and there are only 2 B's here. Are you gonna move every B here, or are you simply just gonna move these 2 lone boys to the big group? Obviously you're gonna move the lone boys to the big group. That was a really nice example. So how are you gonna know that they are smaller parts? Looks like a lot of work. Actually simple. With a for loop we can count what is the position, where does the position begin and where does the position end of a big group of A or B. Also I think we need to do for both A and B. Like we are doing for B now, right? But also we have to do the same for A. Everything that we did for B, same thing for A, and count which which number of operations are less. That is our final result. So first find the big group of A or B. I mean, first let's focus on one part for A, then do the same for B. Might need to use a function here because we are doing the same operation again. Oh. Do we have enough time? 23 minutes. Oh, that's enough. So what do we have here? Test case first. Always. Then comes our n. Then, oh, it says string. We don't need a for loop to get the variable. Just take a string s, say an s, and we have all the input. Now the function. We're gonna pass a first. Yeah, it's a character. Let's pass a string because working with character is troublesome. String is much better. So pass our string, and then it's gonna return us the number of operations. So, the result is simply cout min this function. Twice with s. S. Why did I write s though? It's a and b. That's it, right? And now we have to make the function. This is our answer, right? Function A, function B. Simple. Kidding. How to make the function. Let's take our s, take our target, right? These are target. Do we also need n? We don't need n because we can get n from this string alone. Length is just s dot size. Simple. So n is helpful for nothing. They could have just given us the string and be done with. So what do we have to do first? We have to find the bigger group. To do that, so if we find the target, you have to count group length, group start, I mean that's starting position of the group, group end. So group length first is 0, group start first is nowhere, so -1, outside the range of the array. So each time we find a bigger group, we increase the group length and we put the new group starting position and the group ending position. That's what we need to do. Okay, take a for loop. It's not actually end now, it's length. You know what, working with n is much easier, so I'm just gonna put n here instead of length. I mean, why waste time writing that? And I'm gonna explain less now because I don't have much time. I only have about 18 minutes. So hmm. So si equal target. Suppose for b we are iterating the array and we found b. That means the starting position is equal I if okay, start equal I, and then no, not I but j is gonna start from start plus 1. The length or the size of the group equals 0. Now we don't have to initialize this here, we can just initialize this in this place. You know what, let's put -1 because we might get runtime error if we don't do that. There are reasons why I did that, and I'm gonna explain it sometime else. Size equal 1 because we already took one element and we're starting from the next element. So, and we're going till the end of the array. If sj equal k, then obviously size plus plus. If not, then that is where we end, and end is equal j minus 1 actually before we end. Before was the last element, and we're gonna break from this for loop because there's nothing else to do. So we got the start, we got the end, and we got the size. Now we're gonna check if the size we got now is greater than the group length we had before. If it's greater, then we're gonna change our group length to the size we got from here, and also group start and group end also change. Also gonna change group end. So group start is this start. Pretty simple, right? And this end. So we easily got the bigger group, just like that. I don't know if there is a shortcut built-in function is still like that, but this will work. You know what? Why don't we debug and see if it actually gives us the thing that we want. There should be an inline here. What? Oh, SI is actually a character, not a string. Guess I cannot take string. I have to put character. Okay, what now, bro? K. What is K? Oh, I think the K is because of the previous problem. I thought the target was K. My bad. So the big group here, for A, the big group starts at, the size is 2, starts at 0, 1, 2, 3, ends at 4. For B, the size is, you know what, make it bigger. 0, 1, 2, 3, 4. 5, 1, 2, 3, starting is 1, ending at, you know what, let's put a smaller, let's take this one. A, B, A, B, B, A, that's a big group of A, and then B, B, again A, again B. That's a big group of B, much bigger. A, B, A, B. So we are outputting group length, start, end. So group length is for A first, because it's for A first and then B. A, the bigger group is 3, right? 3, starting with 0, 1, 2, 3, 4, 5, 6, ending at 6, 7, 8, and the B starts here. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The length is 1, 2, 3, 4, 5, 6. That's what we should get if I input this in my program. So TC, the length of the whole array is, let's see, 17, 18, 19, 20, 21, 22. So the length is 21. A, B, A, B, B, A, B, B, A, B, 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 A, B, A, B. Let's go. Oh shit. What did we do now? Oh yeah, of course. I remember. here. Hmm. Mm, because we're doing start plus one, what if the start is the last index? Start plus one is not gonna work, is it? That should solve the... Oh shit. I just lost my the input that I copied before when I copied this. Now I have to write that again. Oh, I'm not actually returning anything, am I? I need to return something. Just return one, okay, for now. Hmm. What's that? 111. There should be a space. How can the position be -1? Oh, they are doing B first. Why? I thought they're gonna do A first because A is on the left side and B first. I guess they do this one first and then this one. I don't know why. So the big group of B starts at 0, 1, 2, 3, 4. Okay. 2, 0 and 1. Alright. Let's check for our this whole thing. What was the size? I think it was 21, right? I mean, I didn't actually need to specify the size because we know that the n is not, I mean, we're not using the n, so it doesn't really matter. 368, 368, 6, 12, 17. Finally, that took a lot of work. Our time ran out already. Anyway, let's solve the problem still. Now that we have that, what we have to do is okay, move the smaller ones to the bigger family. Now let's take it for a loop. If si equal target, and if the target is not inside this range, group start and group end. I mean, if it's inside this range, that means it's already connected. You have to make sure it's not inside this range. And if I okay, so if I greater than equal group start if I less than group start or I greater than group n, that means it's out of the range because it's not inside the start or ending range. Then what we're gonna do is that we're gonna attach that to this one. So suppose this is the group. Let's copy this, okay? Paste it here, take it somewhere else, work on it. So suppose we found this one and we want to move this to here, right? And then the rest of the stuff just moves slightly like that. So the position was here and then we moved that in this position. one of the can choose a position and swap the neighboring characters. I mean, I have to get here by swapping. So starting from this, we have to swap. Starting from I, and we have to go, when we're not swapping here, we're swapping the element before B. That means less than group start. Oh, one more thing. If I less than group start, because if I is greater than group start, then it's something else. You know what? I'm gonna solve this tomorrow because I'm feeling so hungry. I've been in this contest for hours. I guess I'll see you guys tomorrow.